Okay, this is a lesson on 11.2 in your textbook. We're going to be simplifying radicals today. One thing you want to be familiar with are the perfect squares. They're right here. You can pause this video as needed, but it would be a good practice to memorize these. The other thing we have to know are what do perfect squares look like as variables. When I have a variable, x squared is a perfect square, x to the fourth is a perfect square, x to the sixth, x to the eighth. So it turns out multiples of 2 are perfect squares. And so it would be beneficial to talk about the square root of those. If I would take the square root of x squared, that's equal to x. If I take the square root of x to the fourth, that's x to the second. The square root of x to the sixth is x to the third, and so on. The square root of x to the eighth is x to the fourth. One way you can look at this is the following. If I change the square root of x to the fourth as x squared to the second, the idea here is that the square is canceling with the square root. I'll do the same thing with x to the sixth. The square root of x to the sixth is the same as the square root of x to the third to the second. And as we've seen before, the square root and the square cancel, leaving me with x to the third. So in general, if I have the square root of x to the n power, it will be x to the power of n divided by 2. This is a general rule you want to know how to do. So this is the first property we have. We have a product equals this product of the square root. An easy example is something like the square root of 36, which is the square root of 4 times the square root of 9. 4 times 9 is a 36. We can show this is true by square rooting the left side, which is 6. And let's see, this is going to be 2 times 3. And we can see that this is true. And this is true for all numbers, not just simple square roots. To illustrate this property, we're going to look at the square root of 25 is 5, and the square root of x squared is x. We can put these together. An example where we have the square root of 25x squared. The product property says I can square root the 25 first and take that times the square root of x squared, which allows me to simply square root both of these, which is 5 times x. Another example here, the square root of 24. I'm going to look for factors of 24 that are perfect. So factors of 24 that are on this list. I believe 4 is a factor of 24. So I can rewrite this as the square root of 4 times the square root of 6. Seeing that 4 is a perfect square, I have 2 radical 6. Here's a couple more examples. Factors of 20 that are perfect squares. Factors of 20 are 4 and 5, and that allows me to rewrite the square root of 4 as 2 times the radical 5. So we talked about if you have a variable, you want to divide each power by the 2. So what we have here, the square root of x squared times the square root of y to the fourth, dividing each power by 2 gives me x, y to the second. On the last example, you see the numbers mixed with the variables. So what we have here is factors of 50 are 25 times 2. Let's rewrite x to the third as perfect squares. So if we recall, perfect squares are those powers that are even numbers. So rewriting that will look like this. I'll rewrite x to the third as x squared times x, because we learned that 2 plus 1 will give me the 3. So looking here, I've just made this into 2 perfect squares. The square root of 25 is 5. I cannot square root the 2, but I can square root x squared to give me x, and I cannot square root the x. We can now multiply the outside numbers together and get 5x, and multiply the inside numbers to get 2x. 3 more examples here. So we're looking for factors of 10 that are perfect. Factors of 10 are 1 and 10, 5 and 2. None of those factors fall onto our perfect square list, so that stays as square root of 10. But I can rewrite x to the fifth as x to the fourth times x. Once again, x to the fourth is a perfect square. Taking the square root of x to the fourth is x squared, and then I cannot reduce the 10 and the x. So I'm just going to rewrite that as the square root of 10x. So we get x squared times the square root of 10x. When we multiply radicals together, we multiply the outside numbers and the inside numbers. So here I have 5 and 3, and on the inside I have a 6 and a 2. So 15 is the number on the outside, and 12 is the number on the inside. I then have to look for factors of 12 that are perfect. Factors of 12 are 4 and 3. So I'm going to rewrite this as 15 times the square root of 4 times the square root of 3, which allows me to rewrite that 4 as a 2, and my final answer is 30 radical 3. On the last example, we're looking for factors of 24 that are perfect squares. That's 4, which 4 times 6 is the 24, and the x squared is a perfect square. We can now reduce those perfect squares into the following. The square root of 4 is 2. I cannot reduce the radical 6, and the square root of x squared is x. Putting all this together gives me 8x radical 6. The other property we know is if we square root a quotient, we can square root the top and the bottom. So what we're going to have here is we have the square root of 16 underneath the square root of 25, which is 4 divided by 5. On this example, I have the square root of 13 over the square root of 100, which is square root of 13 over 10. One more example here. If I square root the top, I'll get 1. And if I square root the bottom, I'll get y. So the answer is 1 divided by y. There's 2 more examples. Let's see. If I square root the top, I'll rewrite this as 4 times 2, and I'll square root x to the 4th. We have 2 perfect squares. The perfect square here is 2, and then the square root of x to the 4th is x squared. The square root of 9 is 3, the square root of 25 is 5, and I want to rewrite that x to the 3rd as a product of x squared times x, which allows me to reduce this to 3x radical x over 5.